Okay, so for the first one, you want to say let u equal x minus 1.
Yeah, let's do that.
Okay. So when we do that, we're going to do du by the x, and du by the x is 1. So therefore, we just got a straight substitution that du equals dx. So if I can write this down so far, I'm going to be integrating 3x plus 2 over u with respect to u. What do I do now?
Does that mean you can just chuck the 3x plus 2 on the outside?
No, because x is the variable in there.
But you, are you not? Isn't u now?
Well, but now we've still got this one up here. We've got x's and x's on the top and bottom, so we need to be able to simplify those. Okay. So this is where it's a little bit trickier. But from here, if u equals x minus 1, doesn't just x equal u plus 1?
That's the answer.
Is that right? X is just u plus 1, eh?
Yeah.
So now what we've got is actually 3 lots of u plus 1 plus 2 all over u with respect to u. Now we can do a little bit of maths. Can you see the maths there? Hopefully you can. That's just going to be integrating 3u plus 3 plus 2 plus 5 all over u with respect to u. Because now what I'm going to do? Yes, but this is now going to be 3u over u just becomes 3u over u plus 5 over u. The 3u, that part there is just going to disappear, right? Like that. Magic. So now can we integrate that there? That's just going to become 3u plus 5 log u, isn't it? Yeah? Which in actual fact is the same as, what was u, sorry? U was x minus 1, so that's 3 lots of x minus 1 plus 5 log x minus 1 plus my c.
Minus 1.
Sorry, yeah, that should be minus. Is that right? That was it? Yep. Everyone happy with that? Okay, the other way of doing that particular equation is to actually go, okay, let's don't do the substitution method. Let's try synthetic division. What's synthetic division here? Long division? Yeah, thanks, Mr. Tommy. Sorry. 3x plus 2 divided by x minus 1. How many times does that go into there? 3. That must be 3, because that's going to be 3x minus 3. This is now going to be 0, 2 minus 5. That's going to be 5. So it's going to be a remainder of 5. The remainder of 5 divided by that. I'm going to be integrating 3 plus 5 divided by x minus 1 with respect to x. Okay. Synthetic division.
Where's that 3 plus 5 over x minus 1 or 3 plus 5 x minus 1?
Is that better? Uglier, but yeah. Happy with that? And then that there you'd do exactly the same way. Is that right?
Wouldn't that come out as 3x?
Yeah, what's the difference there?
It just does seem to be different.
Right. Was that going to be the same?
Yeah.
Yeah? Why?
It's just because u is x minus 1.
If we go over here, if we do this one even further, this is going to be 3x minus 3 plus 5 log x minus 1 plus c. So that's going to be 3x, that's going to be 3x, that's going to be 5 log x minus 1. So that's minus 3 plus c. I'm going to combine it there, isn't it? Give me a different number. Is that right?
Yes,
Does that sound about right? Do we ever integrate and get a constant? No. Okay.
Why wouldn't you use the first way?
I'm just showing you the two different ways of doing it.
But like,
Are we happy with the first way? Okay. Are we? Can we see the second way?
in
Okay.
the
So when
second
will
way-
we use the second way? Is your question?
Yeah, no, in the second way,
Yeah.
we're using the first way.
Only because I just did it. Only because I just did it.
But
Here's another
once you get to that
example.
point where you've done the synthetic division one, you're then using the substitution.
Well, yeah, but you don't have to use a substitution. Here's another couple of examples. What would you do around this one? You can do synthetic division here, or you can actually just go, this is now x to the power of 4 over x to the power of 3 plus x squared over x to the power of 3 minus 2 over x to the power of 3, all with respect to x. Doing that algebraic understanding, so I'm integrating x plus 1 over x minus 2x to the power of negative 3 with respect to x. So then I'm just going to get x squared over 2 plus log x. What's that going to be? Minus 2x to the negative 2 over negative 2. Does that sound right? So that's just going to be that part there. Is that right? Well, you're integrating x. When you integrate any number, when you integrate x, you add 1 to the power and divide by the new power. This is just, remember, this is just a whole bunch of sums, isn't it? We're taking it from the quotient, the rational expression, into a whole bunch of sums. Simplify the sums, and then you can just integrate x. And integrating x was probably the first one you ever did. Okay? You happy with that example?
Plus C.
Yes, balls. Right. So to finish that one here off, did we have any questions with that one? Was the long division that hard?
No.
Nah. So x squared plus x minus 1, x plus 1, x goes into there. Oh, you want me to do that, do you?
What?
Shush. So this is going to have x with a negative 1 remainder. Okay, you probably just saw it because I was just talking about it. So it goes into x minus 1 over x plus 1.
We're probably wrong, Dan.
That's why I want to time it like x plus 4 to see.
Actually, no, we did.
Okay, there's my answer. Any questions with that stuff? Okay, can you see why sometimes a little bit of algebra might be easier? Because how are you going to use a substitution method on that one?
So what would this just going to that method every time instead of using this?
No, substitution method's really good when you can notice denominator, numerator. There's like a differential derivative there. Substitution method's really easy. Talking about trig stuff. So my default would be go to substitution methods. If it doesn't work, like that one there, x, it's quite hard to substitute into the top line there. Yeah, because u is this. So it would be, okay, so we're going to go, let u equal x plus 1. Yeah? So now u minus 1 equals x. So now I'm going to integrate u minus 1 squared plus u minus 1 all over u with respect to u. And that's going to get a little bit trickier to do. So if it gets a little bit tricky to do like that, that's when I'm probably not going to use the substitution. But they'll still work. Okay. That was still working, that'll get you the right answer. Any questions with that?
See, I'm already 1/6
Alright.
of the way.